All right, so just to backtrack a little, a chemical energy store is battery, food, muscles, or fuel. Kinetic store are things that move. If any kind of system involves height of the, this is your gravitational potential store. Elastic potential store is pulling an elastic band. If you see a nucleus, and I'm going to add some more keywords, some really interesting ones are fission and fusion. Fission and fusion. Currently, they're building a fusion reactor in places like France, Japan, the United States. If we're looking at fission or fusion reactions, or we give you an image of an atom's nucleus, there is a nucleus store. Magnets, I find magnets strange. I really like them. I think they're, um, the reason I do is because magnets have a attraction. So if you have opposite sides attracting, well, they attract each other. If you have the same sides as in the diagram, they repel. So why do I find it strange? Well, how come we don't have the same thing with gravity? Yes, I know I'm attracted to the Earth, but is there such a thing as an anti-graviton particle? And if there was, do you imagine the energy we'd save? That would be amazing. Electrostatic store, that is charged particles. You are either looking at positively charged particles or negatively charged particles. And the negatively charged particle you come across pretty much most of the time is the electron. Now, the other one is if you add up all the energy in terms of kinetic and potential, it is called the thermal store or the internal thermal store. All right. So those are the energy stores. You can then change one to another. There are three main ones, as I said before, but technically four. And I'm going to talk about these first. No, I'm not going to talk about them. I'm going to talk about these first. This is when you pull or push something. This is the mechanical energy or transfer pathway. This is electrical. And we can tell we've got a battery that has got chemical energy in it. And it's been changed to light. And the method, the transfer pathway is electrical. This one and this one are heating. This is heating by particles. This is heating by radiation. Particles means things like you're physically touching a hot cup of tea. All right. Now, we go all the way to here in terms of energy pathways. Here, this is the electrical transfer pathway, the mechanical transfer pathway. Okay. Now, a bit more detail than we've been doing before. Total energy stored before is the same as total energy stored after. So when we're talking about energy systems, they must be closed. This doesn't really exist in the really real world, but this is a simplified version of a system of something we're looking at. So to give you an example, if we look at this Bunsen burner heating up the water, what we say is the heat is transferred, all of it, to the water. Unless we talk about the surroundings and we have to mention them, otherwise heat is lost to the surroundings. So it depends on the energy system we're looking at. The energy store is chemical in the fuel that we're burning. And it's changing to thermal energy. And this is transferred this is by two transfer pathways. One is the particle, because you have hot air hitting it. And two is by radiation, because it's giving off infrared radiation. And here's the energy analysis. At the start point, there's lots of chemical energy and very little. There is some. This beaker is at room temperature. It has some energy, some thermal energy or internal energy store. As you burn the fuel, your chemical energy goes down and your internal energy store, the thermal energy of your in this case beaker and water, goes up. And as you can see, they total to the same amount. All right, so let's have a look. This is a quadcopter. It uses batteries. So as you fly, the chemical store decreases. You cannot say the energy in the battery decreases. We want to hear those keywords. The chemical store decreases. The gravitational potential store goes up because the drone is flying upwards. As it goes up, its kinetic energy will decrease, it will slow down, and it will heat up. All right? Okay. Now, transfer pathway. So the energy from the battery to the motor is transferred down the electrical transfer pathway. The blades spin, these things spin and lift it up, and that's mechanical. Okay. All right, so we've got lots of energy comparisons as well. I've got 6 minutes, I'm okay. All right, now if we look at this, and you'll see the worksheet on this, this is a little springy toy. When you push it down, it's got lots of elastic potential when it is compressed. When you let it go, it bounces upwards. So its elastic potential energy goes down, its gravitational potential energy goes up. Its transfer pathway is mechanical. All right. Now, here you've got a car. The car goes down the ramp. Over here, its energy store is gravitational. It's high off the ground. And at the bottom, it will be moving. It is its kinetic energy store. Now, in this case as well, this is mechanical, the mechanical transfer pathway. Okay. Now, we got energy diagrams. Oh, let's do another one. All right. So if we look at the light, in both these systems, so we've got a torch with a battery, and we've got a motor that has got electrical input, right? Both of them contain chemical store of the battery. They're both being powered by a battery, so they both contain the chemical store of the battery. The energy transfer pathway is electrical, right? Now, in the bottom one, it is transferred via a motor, and the top one is transferred to the bulb, right? So using a motor, it's transferred via the mechanical pathway to make the motor move, and the top one, it will be the electrical, and it will become, or it will be changed to light energy. Right. In both systems, you will heat up the surrounding area, right? In system 3, this one with a torch, it is by radiation because it's giving off infrared radiation. In the bottom one, it's friction. All right. These are energy diagrams. So you've got methane gas. This is a fuel, chemical energy. Heating via radiation and heating via particle movement. So these are all the different kind of energy diagrams you've got. All right. So we can make it quite complex if we want to. So methane gas heats by radiation, not just the water, but also the equipment, the beaker, the gauze, the tripod. And it will also do it by really making the air hot around it. I mean, have hot particles of air hitting it. It will heat the water up, again by radiation and particle movement. It'll heat the surroundings up. So if you're quite close to it, you'd be part of the surroundings and you'd feel it. All right, so I think that I'm coming to 9 minutes. That's a lot of chatting.